Okay, we're going to be talking about motion in this section right here. And when we talk about motion, we're only dealing with linear motion for right now. What that means is either things are moving right, left only. So think of a car just moving forward or backwards, or things are moving up and down. So a rocket that goes up or comes back down. So a couple of relationships that are important to know that you probably have seen before. So let's call S of t the position function. And the velocity is just the change in distance over change in time. So that would really be ds dt, which would represent a derivative of the position. So the first important relationship is that the derivative of the position function is your velocity function. Now, when we talk about speed, speed is non-directional. So that means if a car is moving forward, we say the velocity is 55 miles per hour. Speed would also be 55 miles per hour. But if a car is moving backwards, we would say the velocity is negative 55 miles per hour, but the speed would still be 55. So speed is just the absolute value of the velocity. Okay, acceleration is the next relationship, is the rate of change of velocity with respect to time. So the second derivative position is the same as acceleration, or really the first derivative of the velocity would also give you acceleration. And the last two pieces is if velocity and acceleration have the same sign, then we say speed is increasing. If velocity and acceleration have the opposite sign, then we say speed is decreasing. We're going to talk more about these two a little bit later. But let's start with an example. Let's say a car is moving to the right 10 units. So car starts here, goes to the right 10 units, and then it reverses direction. It's going backwards and moves left 6 units. So let's say go 6 units. So there's two different types of questions you can be asked. If I ask you for the total distance traveled by the car, that's going to be 16. It went forward 10, backward 6, so it traveled a total of 16 units. If I ask you for the displacement of the car, let me move this, that's asking where it is in reference to where it started. So if I look at this picture, really it's 4 units out from where it started. So the displacement of the car in this case would be 4. So make sure those are two different questions. So let's get one more example. So given a position function, this cubic represents the position function. Time is in seconds, the position is centimeters on some interval, and we're only looking from 0 to 9 seconds. And I want to talk about the motion. So when I talk about this motion, let's just assume we're only moving left to right. So anytime you are asked about motion or describe the motion, you always want to look at the velocity function. So I'm going to start by taking the velocity. So if I bring down the 12, that's 24t plus 36. Okay. I forgot the first term, 3t squared minus 24t plus 36. And the points that are going to be important is where this is equal to 0. So I'm going to factor out a 3, and it does factor nicely to this. So your places where the velocity equal to 0 are at time 2 and time 6. So those are places where this particle could possibly change direction. So what I'm going to do is I'm going to create a sign chart, and I only care about from 0 to 9. I'm going to use the times 2 and 6. And what I'm looking for is the sign of the velocity function. And so I'm going to plug in numbers into the velocity function right here to create my sign chart. If I plug in 1, this ends up being a positive, this ends up being a negative, and this ends up being a positive. So what this tells you about the motion of this particle is that when the velocity is positive, assuming we're only moving right, left, this particle is moving right from 0 to 2 seconds. Then it moves left, changes direction, then it moves right again. So it goes here, goes back, and then goes back again. So if I want total distance traveled here, what you need to do is figure out this distance traveled, this distance, and this distance. So you need to find the three separate positions. So what I'm going to do is I'm going to make a little chart with time and position, And I want to know what happens at all of these times. And I'm going to go ahead and plug these numbers back into the original position function right here. And you can use a calculator to punch these numbers out. This is going to be 18, this is 50, this is 18 again, and this is 99. So what this means is that time 0, this particle started at a position of 18, and then it went to a position of 50. So that means it traveled a total of 32 units from 0 to 2 seconds. Then it went backwards, but it traveled another 32 seconds. So when we talk about distance, it's always positive. And then it turned around and traveled forward again, and that was a total of 81. So your total distance traveled would be the sum of these 3 pieces. Now, if I ask you for displacement, though, that would just be the end position, which is S of 9, minus the beginning. I just wanted the difference between start and end. So this would be 99 minus 18, which is 81.